All right. So this past week was the assignment that had you go through the example of a finance sheet and give you some applications for that you could use in your own life, your own management. Covered some functions like sum, things like the index and match, all that kind of stuff that's very useful, as well as in the previous week when we had our gas laws sheet, you did a lot more the functions with syntax, that kind of stuff. We've also been doing some plots, getting some charts in there with data to give you some graphical analysis. And there is a lot in Sheets and a lot of different things that you can do. I've said this a lot, but I use Sheets all the time. I've been scheduling, I've been doing sorts of keeping track of stuff. YTAC uses it for a lot of things. But what I'm going to do is this week is going to be another slightly more specific week with a another use case for Sheets. But I've been covering a lot of the general, more broad topics because I want to be able to help in as many different ways as you can. Sort of build the foundations so that you can take your own direction if you're going into some sort of finance or accounting. You can have that sort of aspect available to you and that way to manage funds, or if you're going into just some sort of directing or advising something, some position where you have to manage employees and you want to keep a large data sheet or something like that. That kind of stuff. I want to be able to have this as a general foundational instruction that you can take your own direction. I know that I've used sheets a lot, even in like my classes, especially STEM classes. But it's a very nice tool to have under your belt. And what I'm going to show today is going to be more useful in analysis, but it's going to be some importing data and then making references and analysis of a more complex data set. You may have seen in that last couple assignments, especially the last one where it was that finance sheet, you're looking at it and I'm having you do functions to add everything up. It's, why would I do that if I can just count the 7 different numbers and just put plus marks between them? That's because we're going to have data sets like what we're going to talk about today. And for example, I just have this air quality sheet information I found. One of the great things about the U.S. government is that they collect a lot of data and it's very accurate. And it's all because it's the public government, the federal government. I mean, it will allow you to access it. So I have done a massive project previously with rates from air quality and COPD, which is a respiratory disease, and it gives you all sorts of information. It gives you years, dates, locations, quantitative and qualitative data sets, and a lot of variety in what you're looking for, and very, very thorough information, which is hard to take in as a single person. As you're seeing for this example, I'll go ahead and start picking through some options. But if I'm looking at Charlotte specifically and I see 400 different readings, that's kind of hard for me to take in as an organic being. But the computer allows you to crunch those numbers near instantly and then give you a very easily digested graphic or analysis that makes it simpler for you to understand. So I'm going to have just pick my pollutant is ozone. We'll just say 2020. I'm going to pick North Carolina. Sorry for all of you non-North Carolina listeners. And then I'm going to find Charlotte. Here it is. Charlotte, Concord, Gastonia, North Carolina, South Carolina. And then this is the sites. I'm just going to say all the sites because I don't really care specifically where in Charlotte. And then you can just hit get data. It takes a little second and you can download CSV. CSV stands for comma separated values and is one of the easiest file types to use with Excel or Sheets or whatever. You can look at your Sheets and what different types of import data you can use, but most of the government pages or World Bank or whatever sort of data source you're getting will use CSV. Now to import, it's very simple. Just go to File, Import, Upload, and just drag it and put it in there. We can get it from your downloads file or whatever. This is where it talks about how it wants to do this. I don't really want a new sheet. I don't want a new spreadsheet. I don't want to replace this. I could append it. I guess I could replace it, but the sheet is like down here, this little subdivision. This goes sheet 1. The spreadsheet is this whole thing, which would include all the sheets. And then if I said append to current sheet, it would just put it at the end of wherever I have data. But I'm going to say replace current sheet. And I'll just use this detect automatically, and I'm just going to import that data. You can see it's loading, and oh, look at all of this. We have latitude, we have longitude, we have county, we have these percents, we have these units, all this stuff. And really, what's the most important thing here, because a lot of this is the same, because I only picked the Charlotte area, the Charlotte Concord area, I don't really have a massive diverse data set. So really what's important is the date, I guess our 8-hour ozone concentration, units are okay. The AQI stands for Air Quality Index. That value is important. And then that's really it for this specific data sheet. Like you can see, I mean, if I scroll down to this massive data sheet, it's all Charlotte Concord, it's all in North or South Carolina. Even if you look at the longitude and latitude of it, it doesn't even change for like more than one whole number of the longitude or latitude. So that's not really useful to provide actual computational results. Not to say that it's not useful, but in our situation, this is what we're looking at. The date, the exposure, the units, which is particles per million, that's what ppm stands for, and the AQI value. This is the meat of it. So for this example, what I'm going to go ahead and do is I'll just get rid of the stuff I don't need because I don't need it. Again, there are certain other things that are useful in there for certain whatever you're looking for. But for right now, I'm just going to take out all that other spam essentially and just kind of work with this stuff right here. And you can see there's a lot of information, and if I wanted to say take an average of everything, going through and saying 13 plus 29 plus 34 all the way through these hundreds, like if you look over on the bar, I'm not even halfway done, over, well over 1,000, almost over 2,000 different data pieces here. That is not easy to do by hand. So this is where these techniques have come in handy. And I'm just gonna, let's say we want to find some information. We'll just find the sum of this information. We're just gonna go down to 2016, and that's our sum of the air quality. That's a lot. And then I'll go ahead and divide it by, I guess that's probably 2015 pieces there, and that's our average. That's just really easy. Get some valuable stuff in there. And what I could also do is, if you remember that COUNTIF function where I said in that example, the COUNTIF, its value is over 8 for that importance on that week 2, last week's assignment. If I wanted to do something similar, I could say COUNTIF, and then next it wants us to give us a range. We'll say that, just all of D. And then let's say we want to know whenever it is greater than how many times it's over 35. And you can see the air quality index value is over 35, 871 times in this specific set, which, by the way, the AQY is essentially a scale from 0 to 500, and the higher the AQI, the lower the quality of the air. Higher number is higher pollution, so you want this to be low. Generally, 0 to 50 is a safe daily value, but we can change this and say how many of them are over 50, and luckily it's only 55. So this is the kind of analysis that you may want to do for your classes, for large sets of data, that kind of stuff. We could also, maybe not necessarily in this particular data set, it won't be super useful, but let's just say we wanted to make a plot chart between our daily AQI and our maximum 8-hour ozone concentration, and we have this very thick line here. Let's just kind of look and see what's best, what looks the nicest for our options here. I think just a line is probably the best, and this shows the correlation now, and that gives you another bit of helpful information. You can see that daily max 8-hour ozone concentration, as that goes up, so does the daily average air quality index value. And then you can go through here, find some information like, ooh, what can I make this that it looks a little better? Here, let's get a trend line in here, and might as well show the R squared, how closely it is. And then I'll just label this as trend line, so it's kind of clogged. And we can see that's a pretty good correlation. And there's all sorts of stuff you can do. You can have your error bars, all sorts of stuff going through this. And this is what leads me into the summary of our upcoming, this next week's assignment for the Google Sheets unit. I don't want you to, let me be clear with this. I don't want you to be writing a full research paper. That's, I'm just going to get that out of the way. But what I do want is for you to find some accurate and substantial data set. When I say substantial, I just mean it doesn't just have your little brother recorded how many weeks it rained and you have 52 data sets and it's in crayon. I mean, like going on to World Bank or EPA.gov, CDC.gov, finding some information and getting some pieces of analysis. With that said, next week's I'm going to say research analysis, the winner will be chosen based on merit. So it will not be a raffle for next week. What I mean is, I don't want to say make the best thing, but give me the most interesting research. Find some correlation. If you don't want to just find, this is a pretty obvious, well, yeah, there's a correlation between having higher concentration and having a higher AQI. If you wanted to, like I said, I have done historically a relation between air quality index and COPC, respiratory disease. So you can take multiple data sets that you're interested in, multiple iterations of stuff. You can find specific regional stuff if you want to do it on a state-by-state basis. For example, if I went over here and I just didn't select anything and I just left it as this, you can see it gives me now all of the sites on here is just all of the states, all of the cities and counties in the United States searching for ozone in 2020. There's a lot of information. You can do some interesting analysis, and there's a a lot of different stuff that you can do that isn't just obviously related to AQI. So, like I said, this next one will be based on merit, and I am the only judge. Not to say that I can be bribed, because I only take cash and we are all online. For legal reasons, that's a joke. But it will be, I will send out like a sort of rubric, the guidelines that I'm looking for in the Discord later. But just keep in mind that just finding two data sets and just, okay, I have here the average life expectancy versus on this side the, I don't know, average number of newspapers printed. I mean, find something that's interesting and not just the two first sets of data you find. But that is all for this week. Just wanted to kind of show you how to import and what kind of expectations I have for this next week. Feel free to reach out with any questions. The internet is a great place to look for inspiration, look for interesting analyses you can do on a given data set. As always, you can always DM me and ask me for any questions that you have. And just a reminder that this will be due next Wednesday at 3:45. It may actually get a little bit of an extension, and the prize pool for it may be increased a little bit, but I will get you that information later today. And that's it for now.